Hi everyone. Today I am going to present my computer vision laboratory experiment on OpenCV image processing. In this experiment, we perform two basic image processing operations: loading and displaying an image, cropping an image. These are the fundamental operations in computer vision because every image processing application starts by loading an image before performing any analysis or modifications. Now, let us understand the basic concept behind this experiment. First, let us understand what computer vision is. Computer vision is a branch of artificial intelligence that enables computers to understand, analyze, and interpret digital images and videos. It allows computers to identify useful information from images such as objects, faces, shapes, colors, and text, similar to how humans use their eyes and brain. To perform these operations efficiently, we use OpenCV, which stands for Open Source Computer Vision Library. OpenCV is an open source library that provides many built in functions for reading, displaying, editing, and processing images and videos. It is widely used in applications such as face recognition, object detection, medical imaging, autonomous vehicles, security systems, robotics, and industrial automation. Image loading and display. Image loading is the first and most important step in any computer vision application. Initially, the image is read from the specified file location and loaded into the computer's memory. Once loaded, OpenCV stores the image as NumPy array where every pixel contains color information. This image can be then displayed in a separate window for visualization. Apart from displaying the image, we can also obtain the important properties such as image dimension, total number of pixels, and data type. These properties help us to understand the image before applying further processing techniques. Function used and working process. In this experiment, several OpenCV functions are used to load and display the image. The cv2.imRead function reads the image from the specified file path and loads it into the memory. After loading the program, checks whether the image has been loaded successfully. If the image path is incorrect or the file path is missing, the program displays an error message. Next, cv2.imShow function displays the loaded image in the separate window. The cv2.wait key of 0 function pauses the program until the user presses any key, allowing enough time to view the image. Finally, cv2.destroy all windows. This function closes all the OpenCV windows. The program also retrieves important image properties such as shape, size, and data type, which provide useful information about the loaded image. Now let us move to the second experiment, which is image cropping. Image cropping is the process of extracting only the required portion of an image while removing the unwanted areas. The selected portion is called the region of interest or ROI. Instead of processing the entire image, cropping allows us to focus only on the important region. This helps reduce processing time, save memory, and improve the efficiency of an image processing algorithms. Image cropping is commonly used in face detection, object detection, image editing, license plate recognition, and many other computer vision applications. Functions used and working process. The cropping process also begins by loading the image using cv2.imReadof function. The image.shape function retrieves the image dimensions which help in selecting the required cropping region. Next, the crop coordinates are defined by specifying the starting and the ending positions. Using NumPy array slicing, image y1 is to y2, x1 is to x2, OpenCV extracts only the selected region of interest. After cropping, both the original and the cropped image are displayed using cv2.imShowOff function. Finally, cv2.imWriteOff saves the cropped image to the specified location so that it can be used for further processing or analysis. Conclusion. To conclude, in this laboratory experiment, we successfully performed two basic image processing operations using OpenCV. First, we loaded and displayed the image while obtaining important image properties such as shape, size, and data type. Next, we extracted the required region of interest using an image cropping and saved the cropped image successfully. These basic image processing techniques form the foundation for advanced computer vision applications such as face recognition, object detection, image segmentation, and autonomous vehicles. Now I will demonstrate both programs along with their outputs. Now let us see the first program, loading and displaying an image. First, the program imports the CV library using import CV2. Next, image is equal to cv2.imReadof. This function reads the image from the specified file path and loads it into the memory. The program then checks whether the image has been loaded successfully using if image is none. If the image is not found or the file path is incorrect, it prints an error message. Otherwise, cv2.imshow function displays the image in the separate window. The function cv2.wait key of 0 waits until the key is pressed, allowing us to view the image. After pressing a key, cv2.destroy all windows of function closes the image window. Finally, the program displays the image properties. Shape gives the height, width, and color channels. Size gives the total number of pixel values. Data type shows the format used to store each pixel, which is successfully unit 8. As we can see from the output, the image is loaded successfully and its properties are displayed correctly. And now I am going to demonstrate the second program, image programming. Again, the program first loads the original image using cv2.imReadof function. Next, height, width equal to image.shapeof retrieves the original image dimensions. The program then defines the cropping coordinates x1, y1, x2, y2. These coordinates specify the starting and ending positions of region of interest. Using NumPy array slicing, cropped image is equal to image of y1 is to y2, x1 is to x2. The required portion of the image is extracted. The program then displays both the original image and the cropped image using cv2.imShowOff function, allowing us to compare them side by side. Finally, cv2.imWriteOff saves the cropped image as cropped output.jpg. From the output, we can clearly observe that only the selected portion of the original image has been extracted successfully, while the rest of the image has been removed. To conclude, this experiment successfully demonstrated image loading, image display, and image cropping using OpenCV. These basic image processing techniques form the foundation for many advanced computer vision applications. Thank you for listening.